We are happy to welcome our keynote speaker, Soma Velayutham. Soma is the Industry General Manager of Telecoms and 5G vertical at nVIDIA. He is responsible to drive adoption of AI and accelerated computing into this vertical. Soma is a successful serial entrepreneur and product leader with more than 20 years in software and high-tech industry. He has incubated and launched multiple software products globally for large corporations. He is also mentor to early stage startups and Stanford incubation program, iFarm. Soma has a BE in electrical engineering, diploma in psychology, and executive education from Thunderbird University. He is an avid promoter of gender and cultural diversity at the workplace. Welcome, Soma. Thank you.
Good morning, everyone. Very happy to be here. I think it's a great initiative. Kudos to the organizers, and I agree with Siva. We need more diversity in AI. So I understand this is a live stream session. I'm not going to get interactive feedback. So I'm hoping to get some feedback from the moderator if anything's right, my audio is right or wrong, or so please do provide feedback. I'll get started. The topic given to me was three things. Let me just quickly look at it. One is current capabilities of AI, the future of AI, and how girls can be part of this future. So that's the key topics I'm supposed to cover. So I'm going to share, hopefully this works. Sometimes it's tricky with Zoom. I'm going to share a quick video. It's a 2-minute video, and then I'll get started with the 20 minutes presentation. So let me start here. Screen, you see this?
Yes.
Okay, good. I'll put it on slide mode, and we'll also get this video going here. Okay, very good. So that is an interesting video. To me, what was interesting was even the music you heard was composed by AI. That's how prevalent. Every single piece of that video was a real company with a real product, and it's not a demo, right? It's working really. So AI is already here. I mean, I think some people don't realize this, that we use AI every day in our life. If you have Android phone or iPhone and you say, hey, Google, or if you're saying Alexa, or if you're saying Siri, that is AI, interpreting your natural language and processing it and giving you an answer. So AI is pretty much everywhere. So let me go about talking about data science and AI. So many times there is a little bit of confusion between data science and AI, and I'll try to break that down. Data science is analyzing heaps of data, a lot of data, and be able to come up with good insights and tell you what's happening and what could happen and so on. Machine learning is a expansion of that. By doing the data analytics, the logic is actually written by the machine itself, right? So it's machine learning. You provide the data, but it's actually, you provide an algorithm to come up with it. You don't write the logic. So in data analytics is you tell the machine, if you find this data, if, then do this and that. So it's a Boolean logic already written. In machine learning, you actually create some features and algorithm, and the machine kind of writes its own logic. And deep learning is just another branch of AI where it's even more advanced, and you do less work, you provide more data. So that's kind of the difference between data analytics and AI. So I usually ask the questions, the difference between, and in these days, everybody says I'm AI, I'm doing AI. So the question you want to ask, if somebody is doing AI is, if I write a piece of software, does the software get smarter over time? Does the software get intelligent over time with more data? Then that's an AI, right? For example, if I wrote a piece of software and it can recognize 100 faces today, and maybe in 6 months from now, it can recognize 1,000 faces. It's the same software, but it's able to get smarter. Then that's AI, right? Because it's learning and improving and continues to adapt, right? That's the key difference between an AI and data analytics. I wanted to set that stage. The modern AI is actually driven by three things: digital data, algorithm, and computing power. If without any one of this, it's not possible. By the way, the concept of AI has been talked about from 1960s. So there are many research papers in the 60s. And most of the work was around algorithm, but there was not enough digital data and there's not enough computing power to execute this. So we call this the big bang of AI, where data, computing power, and algorithm all comes together. And that tipping point was about 6 or 7 years ago. And this is why it's really starting to take off. Another, as I mentioned earlier, the key difference between AI and computer program is computer program is logic and rule based. Even after 20 years, it'll only do the things it was asked to do. A computer program will just do the same thing. 2 plus 2 is always 4. But if you have an AI, what you're doing is you're facilitating the learning. You encourage, like a child, you encourage the child. You say that a house has a roof, has a window, has a door, but there is no extract formula that it always has to be 2 plus 2 is 4. So the child then learns many examples of a house. It sees many examples of a house and is able to reproduce a house to its own style, but it still fits into the form and the rules, right? Or at least the principles. The house has to have a roof. House without a roof is not a house. So those are the key features. Is AI is just like a child. A computer program is like a child. You facilitate learning, not teach them rules. Computer program with logic is rules. AI is facilitation of learning. You write algorithms that learns itself. I want to kind of give you another example. How does this work? Think about you are planting a seed. You give a lot of good soil. That's compute, right? You want to give fertilizers, very fertile soil. That's a computer. You want to give it a lot of data and sunshine, right? Sunshine and water. That's the data. You want to give it a lot of sunshine and water. And then what happens is you plant a seed, which is the algorithm. And the algorithm knows how to grow and become a strong tree. It gets water, it gets compute, it gets water, it gets compute, sunshine, and it grows. You don't have to teach the plant or teach the seed how to grow. It'll know how to grow. So an algorithm is like a seed. The data and sunshine, water and sunshine is like data. And the soil is actually a compute. This is the new world of software. This is the new world of computing, where you don't need people to write computer logic. You just need to write algorithms. And the algorithms will learn and grow itself, right? So you plant a seed, you give them enough data, you give them enough compute, you facilitate the learning. This is what we call a software writing software, right? Because the algorithm will start writing itself and grow from there. No different from a plant growing and knowing how to get to the right place. Now we talked about bias. Siva talked a little bit about the bias, and this is where things could go wrong, because if you don't feed with the right amount of data or the right amount of water or the right kind of water, let's say the water is poisoned or it has some minerals and so on, the algorithm, the tree will have its own defects. Same thing with the compute and soil. So having diversity is very important to have an unbiased data. And unbiased data is a key pillar to AI. Right? So AI is everywhere. You saw the video. We have AI in internet services. We have AI in robotics. Internet services, to give you an example, when you are searching, Google search is using AI all the time. It understands who you are. It understands what you searched previously, what are the keywords you're searching now. It even tries to predict what you might search in future, and it gives you all kinds of recommendations, right? And that's a very interesting use case, and you use this every day in your life. Google search. And then robotics. AI is very prevalent in robotics. I'm not going to go through everything, just maybe touch upon intelligent video analytics. So video is now becoming the number one sensor for AI, right? So if AI can see and hear and touch, the sensors are important, just like human beings, right? We have 5 sensory inputs. Video is one of the top sensory inputs, and AI has really grown in the video analytics to manage and um, to process video. So another very interesting, the last 2 examples is gaming. You don't realize media and entertainment, the amount of AI that's being used. NVIDIA is a gaming company. If any of you girls out there are gamers, I'm sure you would have used NVIDIA technology. So we use a lot of technology in AI in gaming, completing a scene. When you have a gamer who's running around in the screen, you want to make sure you give the maximum fidelity, and you sometimes want to predict, so you can reduce the latency, the jitter, and be able to complete the scene in perfect pixels, perfect resolution. Autonomous driving is another example, right? Today, autonomous driving is a reality. If any one of you have been in a Tesla, or your parents own a Tesla, there is a feature you can actually drive hands-free. It's doing it today. Tesla already has this feature. I drove on 280 in Bay Area here, and I let my hands go. It was a bit scary experience, but it worked. I almost drove the car drove. I was sitting in the car driver's seat for about 6 kilometers, about 4 miles, and the car was perfect. It was just driving itself on Highway 280. So it's all here. So let's not think that AI is this science fiction movie somewhere in the distance. It's not. It's right here, right now. So having your girls participate is very important for us right now. Let's break down AI. I think if you want to break AI down, I would say there are 3 pieces you could see that's very prevalently used right now. The first one is computer vision. In the past, analyzing video was very complex and very difficult. But AI has now really done a fantastic job in computer vision, and therefore using video analytics and computer vision has become very prevalent, very prevalent. Cities are using this for security, airports. So that's one use case. Robots having visions, X-ray machines. So many image processing is probably a better word, but end of the day, computer vision has become one of the strongest areas of AI. The second pillar of AI, which is also very powerful and dominant, is natural language processing. So some of you may realize I have a Malaysian, Indian, English accent. I have a very confusing accent. 5 years ago, when I used to talk to Siri, it would never get me correct. But today, without a problem, it's able to process my accent and give me correct answers. So processing natural language in many different accents and many different languages is one of the very dominant use cases. One example was I had a package delivered by Amazon which was missing, and I called the call center in Amazon, and the conversation went something like this: "Hi, this is Amazon Assist AI. Are you calling us regarding the latest package that you delivered?" I said yes, and it says, "Can you tell us a little bit of the problem? Can you just describe the problem?" And I said it exactly like this: "You know what? I got a message saying the package was delivered, but I actually did not receive the package. I just spoke very naturally. And the AI says, we understand that your package may be missing. If you could give it 24 hours, sometimes, the delivery alerts come ahead of the delivery package. So please give it 24 hours. And if you don't still receive the package, call us back. And the AI was able to completely respond to that. There was no human involved. And I spoke very naturally, just like talking to some operator. So that's how powerful AI has become. So natural language processing is very prevalent now. The next is data analytics or data science, where you're using a lot of data to analyze information using AI. And I told you the example of search engine. That's one very good example. Quickly looking for time. I think I've hit the 25 minutes mark. So that's data analytics. So the key, again, as I said, the difference between AI and any computer program is, can your program become smarter with more data and more time, right? So I'll skip some of these. I think I wanted to kind of show you some examples of AI in public good. You have smarter cities, people providing intelligent services in hotels and stores, and also agriculture. So using AI, there is a company called Blue River, which is now owned by John Deere, which is able to provide identify identify weeds and focus the pesticide usage only on the weeds and not randomly spray, therefore reducing the chemical usage by 90%. These are amazing uses. You know, we all want to have healthier food, and this is one of the clear ways of how AI can help us. So there are many examples. I'm not going to go through everything. So with that, I would move on to, I guess that's it. That's my presentation. I want to say a few minutes just to talk about girls in AI. So first thing is when Siva asked me to touch about girls in AI, and I'm going like, I have a toddler at home. He's 18 months now. And, when we were talking to the doctor about, when would he start speaking and when would he be doing certain things? And the response from the pediatrician was, oh, if it was girls, they would speak faster. They would do everything faster. And, girls are just smarter. That was the response from pediatrician. So I'm thinking when Siva said, you need to have girls more in AI, talk about it. I'm going like, what did we do wrong as a society when you know that even when the children are born, girls are actually smarter? And then when you get to teenage and beyond, why do we think that girls are not participating in the same economy that's taking us forward in AI? So obviously there's a lot of bias being programmed in the community, and I just want to say there's nothing stops you from being the same as, there's no, the gender is equal. In fact, I would actually even think the other way around. I think girls are actually smarter. So there's clearly not a problem of intelligence. It's probably your own mindset and bias in the society, and that's something I hope that you would overcome. And this is not a physical job. This is a mental job.
You may have muted yourself again.
I did not actually. Somebody probably muted me.
No. We can hear you.
Yeah. We are able to hear you.
Okay, so that's it. I think I just wanted to say that it's very important, and I'll say one last thing and I close my session here, is bias is very real in AI, right? Because like I said, data, right? So the data that you feed creates the logic. Like if somebody has never seen food made from, let's say, food made from wild boar, somebody's never seen the food. When you serve them the food, they're going to go really, they're not going to be happy about it because they've never seen it. But if somebody has always seen food made from wild boar, they'll be probably very pleased about it. So what you feed is what you get, and AI is, there's nothing wrong in AI. It's input versus output, right? So the bias is very real, and the data you put in, and the people who feed the data are also important. So having gender diversity, having racial diversity in building AI is very important for making AI democratically useful to the society rather than being biased for certain parts of society or certain functions. So with that, I want to thank everybody for the opportunity. And if you have any questions, you can always reach out to me through the organizers. And as Siva said, we have all the 3 finalists will have an opportunity to talk to um, um, what do you call the girls in AI, the female participants or ladies who work or leaders in AI in nVIDIA. You will get an opportunity to have a roundtable discussion with them. So with that, I wish everybody the best and good luck.